Got interrupted by a phone call, guys. I apologize. So we have and absolute value of x plus 4 is less than or equal to 8, and this and doesn't go there, and x plus 4 is less than or equal to 8. From here, I'm going to subtract 4 from both sides. X is going to be greater than or equal to negative 12. And if I subtract 4 from both sides, x is going to be less than or equal to 4. So we can write this as x, put my negative 12 on this side, and then put my 4 on this side. So we can write it like this, or we can write it all as 1, like it's given up here in the rule. From there, I'm going to graph on my number line. Negative 12, 0, 4. These are going to have solid circles on them. So x is greater than or equal to negative 12, so I'm going to shade this way. And x is less than or equal to 4, so I'm going to shade that way. So in the middle of the two, we will be shading. And that is solving absolute value equations graphically, or algebraically, sorry. Example 3 is a word problem. Reading a word problem and pulling an equation out of it is a big thing that happens on the ACT and the SAT. So making sure you understand how to do this is very important. So our word problem, a machine at a lumber mill cuts boards that are 3.25 meters long. It is acceptable for the length to differ from this value by at most 0.02 meters. Write and solve an absolute value inequality to find the range of acceptable lengths. So 2 things of information that pop out to me. The boards are 3.25 meters long is what it's cutting. And it is acceptable for the length to differ by at most. At most is your key word there. 0.02. That's going to tell you what type of sign you're going to have. So if it's at most, that means that it can't be any greater than that number. So at most means it cannot be that your sign is usually going to be less than or equal to. If it's at least, your sign is going to be greater than or equal to. Because if it's at least something, it's at least 7. So it's at least 7. It can be greater than 7. Or it's at most 2. So it can not be any more than 2, but it can be equal to 2. So once you pick that out, those are my 2 bits of information that are important. So we know we're going to have an absolute value equation. So the boards they cut them to be 3.25 meters long. The boards can be 0.02 more or less. So my length, my actual length, we'll call it L. L, cursive L. L is the length of the board. So L minus my 3.25, the absolute value of L minus 3.25 is going to be less than or equal to, because it's at most, 0.02. So now we have our inequality. We're going to go ahead and solve. I don't have to take anything away from those absolute value bars. So L minus 3.25 is going to be greater than or equal to negative 0.02, and L minus 3.25 is going to be less than or equal to 0.02. So I'm going to add my 3.25 to both sides. L is going to be greater than or equal to 3.23. And, again, adding 3.25 to both sides. L is going to be less than or equal to 3.27. We don't need to graph it. So L can be between, the length of the board can be between 3.23 and it can be no more than 3.27 meters. And that is your solution to that word problem. Your homework is page 67 and 68. 2 through 20 even.